Hey everybody, welcome back. So today we are going to be continuing a discussion that we've started several weeks ago with the idea of how do we persist data within our Android applications. In the past we've looked at things such as shared preferences, and in the discussion forums even several of you have asked questions about the ability to use databases in an Android world. So that's where we're going to talk today. Now today's topic, if you've taken some more, maybe some of like the advanced Windows applications classes, some of this will look a little bit familiar. If you've ever worked with like the Entity Framework or some of those other pieces, some of this will feel familiar to you. If you've never done any of that, that's okay. We'll walk you through all of those topics and concepts together. And I do want to note, though, before we get started, the other thing that's really exciting about this is going to be this week's assignment, while not overly difficult, is going to be really important to make sure you get right. It's going to be the first assignment in a 3-part series that are all going to keep building off of each other. So it's going to be particularly important this week that you get your database up and functioning properly, that you get comfortable with the concepts of inserting and removing data, and other things like that, because next week you'll need to be able to take those concepts and expand on them. And then the week after that, we'll expand on them even more. So for this week, though, what we really want to focus in on is this idea of being able to persist data. So in the past, as we mentioned already, we've used shared preference libraries to do those, which is great when you've only got a small amount of data. It's non-complex data, it's non-related data. Those basic use cases. But what if you have something that's more, where you need to store larger sets of data, you need to store data that's related, you need to store complex data types, more than just strings and integers, other things like that. That's where a database really starts to shine. Now in Android, there are several ways we can approach working with databases. Now the old school way, the original school way, was to use SQLite. And still Android, that's what it runs. SQLite has shipped with the operating system on Android since the very beginning. SQLite is a lightweight database system. It's a file-based database system. So the entire database is stored in a flat file with a lightweight database engine that can easily be shipped and run on devices without a lot of processing power. It gives you a lot of the capabilities you'd expect with an SQL database. With any relational database, you have querying and all those other transactions and a lot of those features. However, working with SQLite in Android presents some unique problems. Specifically, when we work directly with SQLite. Okay, now this is a library that's running on, it's running native code, so your application is actually skipping over some aspects of the Android framework to talk to this guy. And you have to be so very careful. In the Android lifecycle, there's one aspect or a concept called a looper. And the looper, or sometimes you'll see as choreography, in fact you guys have probably noticed in your logcat, or if you haven't yet you will, you get error messages sometimes about some operation took too long and the choreographer had to skip X amount of frames. And that's because in Android, each frame we have roughly 16 milliseconds to complete everything we need to do from top to bottom to keep a smooth user interface experience for our users. And this gets a really kind of complicated sometimes to keep things running quickly and to keep them running smoothly. And this is one of the areas where a lot of developers really struggled with SQLite, is because database transactions and database, aren't necessarily fast, especially as your database starts to get large or you're running complex queries. And the result of this is oftentimes poor applications resulted, poor application performance, and experiences for users. So, the other problem that also came as SQLite took an immense amount of code to write. You had to write and parse cursors directly from the database, which was even more complicated. Just simply connecting to the database oftentimes took, say 100 to 200 lines of code. Just connecting, structuring the database, just the basic stuff, not even getting any useful information out of it, just the basic structure of a database and in the 3 or 4 different classes that it took to make it happen. So several years ago, the Android team started working on a concept to say, well, what if we could abstract the complicated parts of SQLite? IDEs are getting smart enough, computers or the machines definitely got enough power. What if we provided a little bit of intelligence to these capabilities, and we let the computer do what the computer is best at, and let it solve some of those problems? So this is where we're going to learn a new technology as part of the Android architecture components, or is it soon to be known Android Jetpack, known as Room Database or Room Persistence. Now, what Room is it's an object mapping library. It's an abstraction layer for SQLite. Okay, now remember that Room still runs SQLite underneath. Rather, it's going to allow us to abstract the complicated aspects of SQLite, such as managing tables, managing queries, parsing cursors, all of those other mundane tasks. We're going to let the actually let Gradle generate that code on the fly for us as we compile. That way we can just simply make requests and let very well built, very heavily tested abstraction code take care of those pieces. You're going to be much less likely to have errors in your database or in your transactions and failures from those. And I can tell you from personal experience, I've spent more time fighting databases in Android than pretty much any other topic I've ever worked on. Just with TextLater alone, my database related code where I'm working directly with SQLite is roughly 1,400 lines. Not even including sending the text messages or all the UI controls and all the other thing else. Just database related stuff is roughly 1,400 lines of code. Room, as you're going to see, is going to substantially reduce that number of lines, but it is going to take a little bit of getting used to. It's going to feel a little funny, and we're going to have to walk you through the process of how we do this. Now, to kind of explain how Room works, I've got a chart here that I want to show you. Okay. Now, your application is going to have to work with 3 different layers. Okay. Element number one that you're going to work with is you're going to work with entities. Now, entities you should be familiar with. And the whole idea behind Room here is when we're working with entities, you're already working with what we call POJOs, or plain old Java objects. So people are comfortable using Java objects. In fact, when you design an application, 99% of the time you're going to design a Java object to represent something that you need to work with, some individual entity, a class or other things like that are going to have stored variables and fields and all those other pieces. And so the idea here with Room is, well, what if we let users work directly with the entities they're already comfortable with? So entities, with our getters and our setters and other things like that. Okay, those are the first piece, and where we're going to spend most of our time working with these. This also helps it plug in a little bit simpler with the rest of our application. The second layer we're going to need to deal with is what we call a DAO, or a data access object. Now, a data access object is a specially built class that is designed to interface between the Room database and the entities. You can kind of think of it as a middleman. So when we need to retrieve an entity from the database, the DAO will be responsible for that. Or if I want to save an entity, I will send it to the DAO, and the DAO will be responsible for all of the communication between the database itself and the translation between fields and all those other pieces there, and insertions and transactions, all those pieces. The DAO will take care of those so that we can really focus in on the entities, on storing the information we need to store, and not having to worry about the other pieces. Then the third piece we'll have to deal with is the actual database itself. And there's going to be a few new concepts that you're going to need to be comfortable with here. We're going to have to talk about some design patterns a little bit that you're going to have to implement for performance and for reality, really, if you want it to work properly on Android. So these are going to be the 3 pieces we work with. Now, when we're dealing with a Room database, one of the things that's confusing to students is when you're designing the database itself, you actually need to design somewhat back to front. Now, in the past, if you think about with other applications, well, you make a database, and then you make entities, and then you figure out what methods need to exist between them. Rather, when we're dealing with this in Android's world, we are going to start with entities, which are going to be individual pieces of our application. These are going to be those Java objects that represent the thing we're trying to store. So if we figure out what we want to store, then we will figure out in what ways we'll need to access it. You know, what kinds of getters, setters, queries, other things like that. And then lastly, we'll assemble the database. Okay? So step 1, entities. Step 2, DAO. Step 3, database. In that order: entities, DAO, database. Okay? Now, before we can start writing code, though, we need to tell Android how to speak Room, because Room is not part of the Android framework. It's part of it's a library provided by Google for architecture components. So it's tools that are designed to help make our lives easier, to handle common tasks, and to help us conform to best practices. So we need to import those pieces first. Now, what I have here is a class, or a brand new project. It's an empty project with nothing done. All I did is just make a new project. Okay, so the way we're going to bring these pieces in is by adding some files to our Gradle file. Our Gradle file will now then go out and download the necessary source code needed for these, and then we will need to, and then it will compile them and work with them from there. So if we open up our Gradle scripts, okay, when we're in our Android project view, and we want to open up our module. So it's this one here. It says in parentheses module:app. Now in here, as you can see, where we've done in the past, we've had our dependencies. You know, this is somewhat similar to, like, for example, when we dealt with the text input edit and the text input layouts from a couple of weeks ago. We now need to add some new implementations. Okay. So these implementations are going to be specifically for our Android architecture components. So we're going to do implementation, and there are going to be several pieces that we're going to need to bring in for Room specifically. Okay. First off, we need the Room runtime, and then we are going to need the Room compiler. We need both of those pieces. Now, next week when we start looking about how do we connect the database itself to the UI, then we'll need to bring in some other pieces. But for today, just to focus really in on Room for this week, because it's kind of a new concept and students have struggled with it in the past, we're going to focus in on just those pieces. So the URIs for those are I take that back. It is android.arch for architecture .persistence.room. We want to do a colon for the tag, and we want to bring in the runtime, specifically now version 1.0.0. We also need to bring in now with implementation android.architecture.persistence.room colon compiler 1.0.0. Now, it's really important when you bring these in. Why'd you do that, stupid thing? Okay, when you bring these in, the version numbers of our runtime and our compiler must be the same. Actually, you know what? Let's try. We need to do version 1.1. Sorry. Whoa, my computer's going. It's funny. I've got 1.0 in my notes, but yesterday, thank you, Google, they released a whole new version to everything. So our constraint layout is 1.1 now. In fact, there's even a newer version than that just released as well. But we should make those all match. It'll play smoother. So then we'll go ahead and hit the sync button up here in the top. And as you can see here, now Gradle's going to go out and find all of those pieces. We're going to resolve those files. And you can see it downloading those sources right here. And compiling them and going through all of those processes that we'd expect so that it can now work with Room. Our IDE will have the necessary classes so that it can use code hinting and all those other pieces as well. So we're going to go ahead and just let this task finish really quickly. We're almost done. All right, awesome. So Android.arc persistence room runtime, okay, and the compiler. Now, these are both two important pieces here for us to work with, and as you're going to see, we're going to actually work with some new ideas as well, because this compiler portion here of Room specifically is going to be using annotation processing very heavily. Annotations are, as I've spoken with instructors that teach the prerequisite courses to this. That's the topic you didn't cover in your advanced Java class, so we're going to talk about that today. But annotations in short, or this compiler piece that we're going to bring in, is a way that we can provide some hints to the IDE about what's going on so that it can then make an intelligent decisions. Specifically, we're going to give it some important information via an annotation, and then the compiler will now actually write code for us in the background. Which is going to do then the lifting for us. Okay, so when we're designing and working with the Room database workflow, we typically want to try to organize things a little bit in Android. So far, we've only really had activities and fragments, which are okay to leave in the main package. Sometimes, you may choose to group your fragments into a fragment package. It depends. Everywhere you work is going to have a slightly different way of organizing their code. But a pretty universal standard is to put database-related elements in a DB folder. So if you right-click on our main package, edu Weaver I Am Captain Code Room Demo, or whatever yours is called, we're going to choose New, and we're going to choose Package, which essentially is a folder. But a package is going to allow us to organize or to group our code together a little bit more intelligently and help ourselves stay organized. I'm going to go ahead and call this DB. That's a pretty common thing when you get out in the real world, to find all of your database stuff stored in a DB folder. Sometimes now the entities, depending on how you work with those, sometimes they'll be in the DB folder, sometimes they won't. Depends on, again, the different individual shop you're working for. So if I come in here into DB, we're going to come and choose New Java Class. Okay, we're going to define our first entity, because remember, again, our order was we define entities, we define DAOs, and then we define the database itself. We have to have those three pieces: entity, DAO, database. So let's go ahead and define an entity to work with. I'm going to call this entity, just for simplicity's sake, user. We're going to create a database that can store information about users, whether this is a context or something else. This is just real simple to teach the concepts. You guys will then apply this to a slightly different use case so that you get the experience of applying the ideas now to storing and working with a new piece of data. Okay, so we're going to have our entity. I'm going to call this guy user, and it can just be a generic class or a POJO, a plain old Java object. Okay, now when we're defining it, we can go then and define what makes our user a user. What is the data, what attributes do we need to care about with them? So for example, we might want to say, let's have a private string first name. Let's have a last name. So first name, last name, maybe a user ID and an email. Okay, just real basic things, defining a couple of basic variables for us to work with. Now, as you work with in plain old Java objects, we define our variables, and then you would have getters and setters for those pieces. We can do that really easily in Android. If we right-click and we hit Generate, there's an option here for getter and setter. We tell it what variables we want to get or setter. I'm going to hold Shift and click and select all of these pieces here, and it will then create them using these templates. Now, you can get really fancy and define your own getter setter templates, but most of the time I find I just leave those alone. And now I hit go, and now I have a whole bunch of public getters and setters to work with my strings. Okay, so far nothing's fancy, nothing unique. This is a generic Java object. That's why we call it a POJO, or a plain old Java object. Same things you guys have dealt with for hundreds of different applications you've encountered so far in your education. Now, the part where we transform from a plain old Java object to an entity is through the use of an annotation. Now, you guys have used annotations before. You may not realize them. For example, if we go back to our main activity, anytime you do @override, that is an annotation. Okay, we are hinting to the compiler something that it needs to know, specifically that this method is taking preference because we are overriding. Okay, We're going to do the same thing, annotations. We start with the @ symbol for annotation. And specifically, we want to annotate this entire class now. So in main activity here, this annotation applied to just the onCreate method. We want to annotate now our entire class as an entity. Okay. Notice it'll automatically bring in an import statement for you to import the entity so that it knows what entity looks like. So our annotation processor will bring that in. In fact, then you can also provide arguments, as you'll see here with some of the other ones. If we want to define, for example, the name of the table that this entity should be saved as, we could provide that here as an argument in parentheses by telling it the name of the argument and then a value with the equal sign. Okay. Now, every entity, much like what you're working with in databases, we need a primary key, and then we need derived keys from there. So, derived fields from there. The other things that we need to store. So, our first name, our last name, our user ID, and our email. So, we need to define those pieces. We've got the objects here to represent them. What we need to do now is connect the entity or the room database components of the entity to the attributes and the pieces of our plain old Java object. So, for example, if we wanted to make our primary, let's make a new variable for our primary key. Okay, it's pretty common when you get out in the real world that our private keys are almost always just straight up integers, auto incrementing numbers that increment with each one. We may have, while the email may be unique for people, other things like that. We still generally use integers because they're far more efficient when it comes to parsing queries later on. You're certainly welcome to use email or a string like that as a query, as a primary key, but just some real world application context for you. Okay, so if this user ID, for example, was meant to be our primary key, we are going to hint that, okay, with an @ sign, and we are going to say primary key. Okay, now specifically, I want this primary key to be auto-generated. I don't want to have to do it. By default, it'll assume the primary key will be populated with unique data, i.e. like something like an email address. So if we want to change that, I'm going to provide an argument to my annotation so that when the annotation processor is going through, it's going to set this variable auto-generate to true rather than its default of false. The annotation says now my UID field is my primary key, and it should be an integer that is generated automatically by the system. Okay. We can also apply other pieces. For example, if we were to not be lazy and expand these out a little bit. That's what I get for being lazy in my code. Okay, it can be done in the other ways. It's just way too complicated. So, for example, if I want to tell it, by default, Room will use whatever the name of my variable is as the column name in my table, the underlying table that it's driving it. Sometimes we don't want to have them coupled like that. We want to have some separation with those, especially useful if you ever have to change the name of the variable for some reason. Having your column information be different, or if you need to re-specify it to work with what was working previously, you can do that as well. We can specify that through another annotation called column info. And specifically, I can say now that for a column, I want this name to be first_name. Okay. Again, I don't have to define this column info because by default it will use whatever the field name is. But if I want to change it to use, say, first_name, okay, then I would do that, which is useful because SQLite does tend to get a little fickle sometimes with camel casing. The Room database is smart enough to deal with all that for you, so you don't have to worry about it. But if you want to, you can come in and say last name, for example, just so you can see how the components work. I'll leave user ID and email without an annotation processor, or without column information being specified for them, so you can see how that works. Okay. Now we added a user ID, so let's go ahead and generate now a getter setter for for that user ID as well. Okay, I'm going to put those down because I'm OCD and I like things to be organized. Okay. Now, the other thing we need to have now to work with our entity, especially since we've decided to make these fields private, is we need some constructors. So again, if we go to generate, we can choose constructor and tell it what pieces we want to accept as an argument. So for example, if I wanted to be able to construct an element with all of my pieces, I'm going to then select them all. So when I generate my constructor, by default, I just have a basic constructor that accepts all of my fields as arguments and will assign them to the appropriate variable name. Nothing fancy. Okay? But we have an entity now. Again, the thing that separates our entity from a straight POJO is the annotation. Okay? So when I compile this application now, what's going to happen is part of the compilation phase, the Gradle program will actually scan all of our annotations and send them through what we call an annotation processor, looking through all of those tags and then doing whatever the code says. This code for an entity will actually tell it how to build an entity and what to write. What code pieces need to be written in the background to support this functioning properly. So we have an entity with a primary key, and I've specified unique column information for 2 of my fields, but again, that's an optional piece. Okay? That was step 1. Step 1 was to define an entity. Step 2, as you'll remember, is to define the DAO, or the Database Access Object. Now, unfortunately, we have to run all of the pieces before I can show you this functioning. So, again, inside of my database now, I need to make a new class. And I'm going to call, by default, the way the practice in the industry, I should say, is to name your DAOs the name of your entity followed by DAO, all in caps, like that, DAO. Okay? That's the practice you're going to see when you get out in the real world. Sometimes the AO like this is lowercase. But more often, most of the time I've seen it, they tend to capitalize it all the way through because it is an acronym. Okay, this is a database access object. Now remember, this class we are making now specifically to work with Room. Okay, this is not an entity like we've done in the past, but rather this is an interface. This is that middle layer between our entity and our database, so that when our application needs now to work with entities, we will send those entities to our DAO or retrieve those entities from our DAO, who will then work with the database. Okay. Now the DAO itself is just an interface. I forgot to change that. Sorry, when we constructed it. The DAO is an interface. It can be an abstract class if necessary, but an interface is usually sufficient for the majority of needs. Okay. Now the reason we're defining an interface here is because we're not actually going to write much code here. We're going to define what methods of interaction we need, and then we're going to let the compiler write the code for us. Okay. We're going to let the Room database engine figure all of those pieces out. That's what that compiler piece we brought in through Gradle was to process and compile those annotations. So we have our DAO interface, and we're going to need to define that it is a DAO. So we say at DAO. Okay, again, it'll now import DAO for us, and we now have a DAO. Our DAO is pretty useless because we don't define any methods. But for example, we may want to say define some basic things, such as how about, what if we wanted to have a method that allowed us to say get all of our users. Okay, now our get all, say, might return a list object of users. Okay, we'll have to import list. Oh, come on. Okay, we need to now tell DAO how this connects. So we have a method that our interface does, but now we need to make this method now intelligent to Room. We do this by specifying now what is with another annotation. Specifically, in this case, I want to run a query for this. We import that again. Okay, our query for this is probably going to be pretty simple. We're going to say select all from user. Okay, we have our query. Okay, and you've got linting through here, so you got code hinting, you've got colors, all the usual things you'd expect when you see a query, which is really useful. So now, though, DAO will know that this method needs to run a query in the background to select those things, build instances now of those objects user, and return them to me in a list form. All of that information can be inferred here, and all of the necessary code to connect those pieces and run it will be written for you. You don't have to do jack squat beyond that. Okay. In fact, we could, provide more complicated queries if we wanted to. Maybe we don't want to get all of our users. We want to find, let's say, return a list of users. Oops. Fingers are hitting the wrong keys today. Based on a specific ID. Say we want to say load by ID and provide an integer of an ID that we're looking for. Maybe we're looking for a specific one. How do you provide an argument? Okay. Again, we are providing a query, and I want to say select all from user where UID, I think is what we called it, right, in our DAO, was UID, okay, equals ID, okay. This named parameter, when I put a colon in the front, okay, is a named parameter, meaning the name that I put here and here. So I'm telling it where in my query to use the variable that I'm providing as part of my argument. And we could even do more fancy stuff. You could use an in statement to say, if you wanted to find all of your users who had the same first name, for example, or the same zip code, or other things like that, we could use an in statement. All those same SQL statements that you would expect to work will be functional. Same thing. Maybe we want to find a single user now based on we've been using before. Let's use load by email. Or maybe you want to do it load by, actually let's do this, so you can see several together. Let's do it load by their name, providing a first name and a last name. Again, at query, and I want to select all from user where first name equals first and last name equals last. Limit 1. Okay, standard SQL query. Find the user, and this will now go out and return a user object or null to us if it's not found. So queries, this really allows us to focus in on the complicated stuff. Now, when you guys, for example, are working with databases in the past, and say you need to insert stuff to your database, how many times do you have that syntax completely memorized, or update syntax or delete syntax, the stuff that's always the same? Or do you sometimes have to look it up, or do you wonder, like, this is always the same, why do I have to deal with this stupid boilerplate code? Well, here's the cool thing, is you don't need to with Room. So for example, let's say I want to provide an update method that will take a user object and just update it in the database. All I have to do is tell Room that it's an update. Same thing. What if I want to, say, delete a specific user? Well, tell it it's a delete query. These queries are, there's only so many ways you can write those, right? An update query is simply going to do a where clause to tie me to my primary key, and then set the fields, and then run the query, right? There's nothing complicated in an update statement. Rather, we'll let this thing do the work. Same thing for a delete. I mean, a delete query is simply, delete from user where PID, primary keys match. So why should we have to worry about that kind of stuff? Why can't we let the user, the database do it for us? Same thing. Maybe we want to have a method to insert. And we can even get fancy with it. Say we want to implement insert, be able to pass many users to it. We can use an ellipse. This will allow us now to pass multiple users to this method, as many as we want, and go ahead and just insert them for me. I mean, the insert statement follows the same structure every single time. So why should you have to write that? That's the whole idea here, is simplifying the pieces you don't need to worry about so you can focus in on the stuff that really matters, the stuff that's complicated, the stuff that takes some thought, the stuff that takes, developer's touch, working with your selects. But updates, deletes, and inserts, they're dumb. Just let the machine do it for you. They're the same thing every time anyways. And I could write a update statement via a query if I had to do something fancy, or a delete or an insert. Same thing, if you ever have to do something fancy, you can do those by the @query annotation, but the vast majority of the time when you're doing just those same templated behaviors, these annotations will take care of those pieces for you, so you don't have to deal with it instead. So now this gives me a DAO. This gives me an interface object that I can deal with, okay, or an interface for an object. The last piece now is we need to define the database itself. So we're going to come and make another Java class, okay. A common convention you'll see for this when you get out there in the real world is a class called AppDatabase, because again we want one database for our entire project typically. It does support multiple databases if needed, but typically it's going to be just one database, okay. So we have an app database for us. Again, we need to use an annotation to tell the IDE here that this is a database class. The database class now needs to know several things. For example, it needs to know what entities exist. Okay, it needs an array of those entities. So for us, for example, we said, well, you're going to work with a user class. Now notice I'm passing it the .class version of it. I'm not just passing it user, meaning it needs to have the compiled version of the POJO. Okay, that needs to have that class signature of our entities for it to function with. Okay, it's also, the other required element is it has to have a version number. Now, a couple of notes really quickly about version numbers. Okay, if you decide to make some changes to your entity or your DAO, okay, after you have released your application to the real world, that's when you would update versionings. And then you would now come in and write what we call a migration, which is some methods that tell it how to move from version 1 to version 2. Did the database change? What data information is saved? What information is gone? All of those processes. Now, as you're developing this and you're working kind of piecemeal, and let's say you're working on it and decide to add a field to your entity, and you're running it on your same device or your same emulator. Okay, if you've already run it once on that device, okay, and you've made a change, you're going to get errors, and I'll show you those later. And that's to be expected because you've changed the database signature. So otherwise, it's going to have to know how to change between those signatures. In those cases where you're testing, though, don't worry about writing migrations. It's completely not worth it because nobody's going to actually need the migration. It would just be your testing data. In those cases, uninstall the app completely, or go in and nuke its data, so erase the databases through settings, and then rerun it again, and it won't complain anymore. Okay, but that's just something that students will run into a lot, and I'll show you that a little bit later. So we have our database with our entities. Or a comma delimited list is you need to provide more entities, just provide them in a version. There's other options here that we could go into, but I don't want to I want to focus in again on the getting you guys up and running and focusing on those main concepts. Okay, now this class needs to actually have something unique to it. This class for our app database actually needs to be abstract. Okay, because as we're going to write it here, it could never be implemented. It doesn't have any of the necessary code. We have to wait for the Room engine to compile and write the necessary code that comes on beyond it. Okay? Now, our code needs to extend from the parent class because that's going to provide a way for us to access all of this other code that it's going to work with. So our abstract class app database, we're going to provide the basics of how we will work with it. Okay, by providing the default behaviors here with abstraction, and then the compiler via our annotation will add on to what's already provided via the Room database parent class to give us the functionality. Okay, you can see why we're focusing just on this one topic. We're doing a lot of really complicated things here just to get the database working, and just in a couple of lines. Okay, so we have our abstract class app database extends Room database. Now, when you're working with room databases, by convention, okay, we're going to follow a pattern known as the singleton pattern. The singleton pattern is a design pattern that allows for a single instance of a class to exist ever. We do not allow multiple instances of our class to exist. We do this because constructing the database objects is pretty intensive on the device. It takes a decent amount of memory, it takes some time, and you do not want to construct one of these every time you need to interact with the database. Rather, we're going to construct it once, store it, and then just work with that singular instance. Okay? Now, the way we provide that capability is we're going to take advantage of static classing. Okay, or static objects. So we're going to define a private static member variable, meaning this variable will exist across all instances that were ever created of this object of type app database, okay, of our abstracted class, and we're going to call it instance. All right, once we have an instance, a place to store an instance, now we need means to access it. Okay, with the singleton, we're going to store that one instance, and that's how we're going to restrict it now to just one instance of it ever existing. Is we'll store it now in that static context, but we need to provide a mean to get to it. So, public static app database, and we typically call it get instance because it's getting the instance variable. Now we will need to pass one argument here. We specifically need a context. Now a context in Android, let's go ahead and import that, is a class or a means of representing the permission set that you're going to be using to get data. So the underlying app or operating system will need to have access to this instance or to those permissions, and that's all handled through a context. That's part of the Android framework. Your activities extend from context, so you often use it those ways. Okay. So, anyways, the first thing we want to do though is first check to see, do we already have an instance? If we do, meaning it's not null, then just go ahead and return that instance. If, however, otherwise, if we don't have an instance, we need to construct one. So we need to first construct it and store it, and then we'll later return it. The way we can construct it is through room. There is an inner class or a method here called database builder. Okay, again following that factory pattern. How do we construct one of these? The first argument it has to have is a context. Okay, because again that's going to define permissions to the underlying file system to access SQLite. The second thing, it needs to know, okay, well, what class, what room database extended class are you working with? In this case, that is our app database. It's this class. So we're going to do appdatabase.class because we want the class signature. Okay, and then lastly now is it needs to know a name. This is the file name that's going to be used to store this. So we might call this a user database. Or just sometimes it's database. The name's not really critical, it's just some name that you like. And then we will call build. Okay. So this will construct, database builder will essentially, what it'll return now is a factory that knows how to build an instance. Then we trigger the build on it. Then once we have an instance, we can just return that instance. Okay. Now you might be saying, well, why didn't you check to see if the instance is null and then build it, and then you only have one return? That's 2 less lines. The reason we structured it this way is actually for efficiency. Now this is not a major efficiency gain, but little things start to add up. Okay. The vast majority of times you're interacting with your interface, in fact, every time except for the first time, instance will not be null. So one quick check and we're gone. Otherwise, we'll be checking skipping, so we'll be branching, if you think back to your architecture class, unnecessarily if you structured your code the other way around. So by structuring it first in a singleton pattern like this to say, do I not have one? Or if I have one, go ahead and return it. Otherwise, make it. Okay. Alright, so now we have a DAO that we can work with. Or a database we can work with. We have a DAO that we've defined and a user. Okay? This is an instance. However, the database doesn't do anything because we haven't connected the database now to our DAO. So, because again, remember our DAO is an interface. It's a non-constructible object. So we need to define a method here inside of our abstract class that we're going to define it as abstract because, again, it needs to be filled in. It needs to be built by room. that returns an actual instance now of our user DAO of whatever underlying class conforms to that. And there we go. Okay, this is the how we are going to access that DAO now. Okay, we have the DAO itself, and now we need to access the DAO. Okay. So this gets us set up through our entity, our DAO, and our database. Okay. Now, in our next video, I'm going to pause here because this one's getting really long. We're at 48 minutes already. In our next video, what we're going to do is talk about now how do I use these pieces? How do I consume them? And how do we do it in such a way that we're not blocking the UI? How do we constrain still to that 16 millisecond requirement of the loop? So we'll see you in the next video.